Okay, last review day, getting ready for the pre-calc final, and I was asked a question about inverses. Like what are inverses for? I'm going to go through like a really quick reminder of inverses because they are a big part of the test on inverses. So let's say you had this inverse sine of, let's say, 2. What is an inverse sine? An inverse sine means that you don't know the angle, but you know the sides. That's what you use inverse for. Like, I'll develop why you'd ever need it. Say you had this. Sine of theta equals a half. Okay, I don't know what the angle that is. That's the point. The problem is they don't know the angle. They know the two side ratios, but they don't know the angle. Then you can rewrite it like this. It's just a way to rewrite it so theta is alone now. Now I've got inverse sine of 1/2. That means I want the angle that goes with the sides 1/2. All right, another way to think of inverse is if you're going, you needed to know this, right? Okay, good. Just want to make sure you're still with me. The inverse on the graph-wise, here's a sine graph. And the sine just keeps going up and down and up and down and up and down forever. But only part of this would have an inverse. Why? Because to have an inverse, you have to have a situation where between here and here, it'll pass both the vertical and horizontal line tests. So sine only has an inverse in certain spots. And this is the closest spot to the origin. So it's between this spot and this spot, which is pi over 2 to negative pi over 2. That's why the inverse of sine only exists in there. So when we say that we draw you this little picture and we say, where is inverse sine allowed? It's only allowed between positive pi over 2 and negative pi over 2. Remember this one? That's why inverse sine is only allowed in that little zone, because it can only exist where regular sine here passes the vertical and horizontal line tests. So inverse sine is like a different way of doing the function, where instead of doing like a typical sine of 30 degrees, where they give you the angle, it's meant to go the other way, where they give you the sides. All right, last thing I want you to know about sine, inverse sine is, like, for instance, what if they asked you what is the domain and range of inverse sine? So it's not a theta, actually. The domain and range of inverse sine. Inverse sine's domain and range are the domain and range of regular sine flipped. So regular sine's domain and range, remember, you can only use part of it, only use this part right here. So what is the domain and range of regular sine? It's from negative pi over 2 to pi over 2. That was the domain. And what was the range? It was from 1 to negative 1. And it can be all of those things. They're all brackets. So then if I want inverse sine, domain and range, it's the domain of this is the range of that. So it would be from 1 to negative 1. And the range is the domain right there, negative pi over 2 to pi over 2. So that's a pretty thorough big picture review of what inverses are. And I just used sine for an example, but the same thing could be said for cosine and tangent. All right, now we get to get down to problem number 39 in the packet. That's where we left off last on the packet. Everybody get to problem number 39. 39A. And 39A says sine of inverse tangent of x. Now, what I was just trying to tell you there was that how inverses work. And we have to start with an inverse right here. And I'm going to put x over 1 to remind you that when you are doing an inverse, they've given you the sides. They didn't give you the angle. They gave you the sides, and really they're always giving you two sides. So if they say one of the sides is x, then the other side has to be 1. See, they've given you two sides. So if I'm going to draw a triangle here, and I'm going to draw it like this, and I have tangent of this. Tangent means opposite over adjacent. Opposite sides x, the adjacent side has to be 1. And notice if I've given you two sides, can't you figure out the third one? Yeah. Remember doing these? I don't know. It's been a while since we've done these. So opposite and adjacent were x and 1. And this side here has to be the square root of, and it's a squared plus b squared, right? So then it's got to be x squared plus 1 squared. So x squared plus 1. Now I know all three sides. So now, for instance, if anybody asked me what the sine of this angle was, which is what this problem is, the sine of that angle, sine is just opposite over hypotenuse. Here's the opposite. Here's the hypotenuse. So it's x over square root of x squared plus 1. And a lot of people make the mistake of actually trying to do the square root of x plus 1 and thinking that, oh, that would be just x plus 1. But it's not. Because it's a square root and there's an add in here. That's what messes it all up. So anyway, bottom line is you'd leave it just like that. Don't try to simplify the bottom. There's your answer. Yes, sir. Yes, you may. All right. Yes. We will eventually get there, but I'm going to follow through the packet pretty consistently here so that I cover every topic. All right, and if you've already done number 40 and you totally understand number 40, then feel free to work on other stuff, but I'm going to keep kind of going through one step at a time so I don't miss any topics. All right, number 40. If tangent of theta is equal to negative 5.32, find cotangent. Well, my first thought on this is tangent is negative 5.32. Obviously, I'm not going to know what that degrees is. That's not what they want. They don't need me to tell them that it's like 23 degrees. What they need me to do is like set up a little triangle for this. Go tangent of this and this little triangle is opposite over adjacent. The opposite side is like negative 5.32. And I guess if it's negative, it's probably going down. So let's go a triangle like goes like this. Tangent negative 5.32, and then the adjacent side is like 1. Well, what is going on? I need to find the cotangent of this. Do you remember that cotangent and tangent are just a flip of each other? So cotangent is just the exact flip of this. So therefore, instead of opposite over adjacent, it's adjacent over opposite. So the answer is the cotangent of that same angle would be just flip them around. 1 over negative 5.32. Sure, you didn't really need the triangle to think of that, but I like to go back to the triangles because so much of it comes down to the triangles. When I talk to the calc teachers, they always say, hey, it's just all triangles. Just get them to do triangles because that's what you got to keep thinking about, triangles. Even the circles end up being triangles. You know, when we're drawing our circle thing and we got all students take calc, it's because we're going to end up drawing a triangle over here. You can do a lot of complicated trig stuff, including the calc stuff you'll need with triangles. Okay, let's move on to number 41. Write in logarithmic form 4 to the third equals 64. All I want to know is, can you write that as a log? And you should log base what? 4 of 64 equals 3. And that is a correct statement. If you think about it, that 64 could be written as 4 to the third, and then you'd know that it was 3, right? So anyway, this is just checking if you can take a exponential and write it as a log. And the next problem is just the same exact thing, and I do want to cover it just, even though it's really easy. It starts as a log, and this is problem 42. And you got to have to rewrite this, but you got to know that that's ln is log base e. And then a rewrite of these, you always go to the other side and then come back again. So e to the third equals x. Yes. All right. Base change. That also means, like, how would you put it in the calculator? For problem 43, how would you put that in the calculator? Log base 3 is 17. My calculator doesn't have base 3. So what do? Log 17 over log 3. You changed its base. Now it's base 10. It's just log 17 over log 3. All right, moving on, 44. Convert to degrees, pi over 10. As soon as you see this, I hope you know you have a fraction with pi and 180, and then you just got to figure out which way to do it. It's either 180 over pi or pi over 180. Personally, I'm going 180 over pi because that way the pi's will cancel. And I can just make it 180 over 10, and then it'd be 18 over 1, so it's 18. So I just figured out pi over 10 is 18 degrees. All right. On to number 45, kind. Convert to radians. Well, if I have 70 degrees and I need radians, same deal. It's just if you try doing 180 over pi again, it's not going to work so well, and you'll realize, wait a minute, nothing's canceling. So you have to flip it. So it won't be too bad to do pi over 180 then, and do some canceling. Cancel the zeros here, the degrees cancel the degrees, and it's 7 pi over 18. All right, moving on to number 46. Name two positive and two negative angles that are coterminal. That means in the same exact spot as 510. Well, first of all, where the heck is 510? Positive goes around this way. That's positive 360. How much more do I need to make 510? Well, this will be another 180. So 360 plus 180. 180 will make 540. And that went a little too far. So back off 30 degrees up from there. So it'll be like there. So what they're asking is, what are some other angles that I could go there easier? If this is backed up 30 degrees off of that, then wouldn't you agree that that'd be the same thing as 180 minus 30, which would be 150? So 150? 150 degrees gets you to the same exact spot. How about a negative one that gets you to the same spot? Well, you could go back this way, 180 plus the 30. And that gets you to the same spot. 180 plus 30 is negative 210. Those are angles that are coterminal. And if I want another negative one, I can just go all the way around and come back. So add another 360 to it. Okay, I think you get the idea there. Moving on to problem 47. It says, what's the reference angle? That was one of the very first things you needed to learn in this. As soon as you had to go beyond 90 degrees, you'd never even seen anything bigger than a 90-degree angle for trig. And we did like this one, where it was 90 plus another, let's say 60, is 96 is like a 150-degree angle. If it's a 150-degree angle, we couldn't really use that. We had to use this angle here, which was its reference angle. So this was 30, for instance, goes with the 150. And this would be the reference angle for 150. It's the angle you could use to make the triangle to keep going with the trig. All right. So since the problem is given in radian-like units of 45 pi over 3, I'd recommend you stick with radians because it doesn't say to change the degrees. Now remember, sorry, 14 pi over 3. So I'm going to redo number 47A with the exact numbers here. I was just saying in general, that's how they work. Now here's specifically 14 pi over 3. Since that's in radians, I'm going to leave it in radians. And I'm thinking, where is 14 pi over 3? Here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6 pi over 3, 7, 8, 9, 10, 11, 12, 13, 14. That one's 14 pi over 3. Okay, so then if that's 14 pi over 3, could I make a right triangle with this right here? No, I couldn't. So I have to use its reference angle, which would be that one. And that right there would be the angle we're talking about. If these are pi over 3s, that's 1 pi over 3, that's 2 pi over 3. How much is the reference angle? Just pi over 3. And pi over 3 is the same as 60 degrees. So pi over 3 is what I'd recommend you use. That's the reference angle. It's the angle that you can use that's like 14 pi over 3, but makes a right triangle. Okay, so figure out where it is, and then figure out the one that would make a right triangle. All right, next is number 48A. It says tangent x cosine x. All right, some of you guys are not still following me. Use your pencil, be writing. If you're writing on a different problem, that's fine. But don't just sit there. All right, number 48, part A. Tangent x cosine x. My first thought is, this must be those identities. Now, I've given you a list of some identities. There's some in the packet, and then there's some that I've just kind of referenced in the past. Would you like me to remind you which ones you have to memorize? Okay, then here are some that you need to memorize. One that would be handy right this second is tangent. Can anybody tell me what tangent is equal to? Tangent is sine over cosine. So how would that be handy in this problem? Because as soon as I put this tangent being sine over cosine right there, I'll have sine x over cosine x times cosine x. And then these guys will cancel, and the answer is just sine x. Done. So that's number 48. But the point is, I needed this. What's another one like that? Cosine of x, which is the flip, right? They're the flipping sisters of each other. So what will it be? Cosine x over sine x. And yes, that's the same as 1 over all of this, but... Okay, cotangent. I meant cotangent, not cosine. Sorry, you're right. I confused some people there for a moment. We'll talk about cosine in a minute. Cosine's just 1 over its sister, which would be 1 over secant. Is that what you were going to say? All right. Okay. All right, so there's tangent and cotangent. Let's go through some of those inverse ones. Sine has an inverse. 1 over what? Cosecant. This, remember, I've been kind of trying to give you a list of things you should memorize and things you could study at the last minute that could help. You know what I mean? Because if you're going to try to learn a really complicated process at the last minute right before the final, it's not likely to work. Okay, but if you're going to go over 4 or 5 little things that could help you in problems, this would be one of them. Sine, cosine, 1 over what? We just said it 2 seconds ago. 1 over secant. Tangent, we just used it. 1 over cotangent. Or there's another thing. Sine over cosine. Sine, cosine, tangent. And of course, cosecant is the exact flip of sine, just like we just did, like that. So then if I write cosecant x, it's going to be 1 over sine. And if I write secant, it's going to be 1 over cosine and all those. Okay, those are called the inverses. Then there's another big family of them that all started with this. Sine squared plus cosine squared is equal to 1. And why was that? Because when we had our little triangle here, and this was x, and this was y, and this was 1, we realized eventually that sine was the same as y. Because sine is opposite of hypotenuse, and the hypotenuse is only 1, so then therefore it's sine. And sine y kind of go together. Try to remember that, sine y. And the cosine goes here, so then this squared plus this squared has to equal 1 squared. All right, and then we had those snappy little sayings. The one with the tan is what? It's the one with the tan, and these are only unsquared, is what we seek. And what was the other snappy saying? The one with the coat is cozy. All right. There are many more. There are ones on the packet that are like the sine of negative theta equals negative sine of theta. But at least those are given to you on the packet. And if they're given to you on the packet, they're going to be given to you on the test. So you don't have to try to memorize those. But these you'd have to memorize. There's more. There's like sine of pi over 2 minus theta is equal to cosine of theta. I mean, again, those are given to you. So these are the ones that I've just written down that you have to know. Yes? The red one or the black ones? Okay. They only work if they're squared, if that's what you mean. They have to have a squared on them, otherwise they will not work. So secant is not the same as 1 plus tangent. Secant squared is the same as 1 plus tangent squared. Yes? Oh, like this? No, because it's in your packet, but you should know generally that that's sine goes with the cofunction of sine, which is cosine. And then it's really not that hard from there. It's that one. Why? Because these two numbers have to add up to 90. Look, that and that. Minus theta and the plus theta cancel each other out, adds up to pi over 2, which is 90. Okay. I think we should do one more identity one. Let's look at 48E as an elephant. 48E. And that says 1 minus cosine squared. That sounds familiar. That sounds like sine squared plus cosine squared is equal to 1, except the cosine's been moved to the other side, see? And now I've got, I need a theta here technically. Sine squared is the same as 1 minus cosine squared. So I can replace the top with sine squared. And then it'll be really easy. And it ends up being sine squared over sine. And do you know if those can cancel or not? Can they? Yes, they can.
Can you do a harder identity?
Yes, I can do a different one. Let's do C. We can do, oh, C is pretty easy. C, you just have to look on the sheet and find what sine of negative theta is off the sheet.
Can you do I?
Let's do I. Okay, I can do I.
It's not too long.
Nah, that's a piece of cake. 48I. All right, I want to make sure for a second that that isn't one of the ones that was changed. Okay, now that was an accurate question, so let's do 48I. Secant squared x plus cosecant squared x. CSC? Yep. Do you remember that strategy of change them all to sine and cosine? That might come into play here. Let's see if that could work. Minus tangent squared. All right, let's change them all to sine and cosine. Secant squared would be 1 over cosine. Plus cosecant would be 1 over sine. And I'm going to subtract from that sine over cosine. Plus cotangent is cosine over sine. Okay, that didn't work so nice. That was not a great idea on this problem. But hey, I gave it a shot, and you should know that strategy. And that, it didn't like make it all better. Okay, I don't have a common denominator. I mean, have fractions. I didn't have fractions before. I don't like this. So there's probably some other way. Seriously, this is the way these go. You got to try something, see if it made it better. Didn't make it better. Let's try something else. Well, I do know some snappy sayings about these things. The one with the tan is what we seek. Remember that? Oh, wait. So you're saying instead of secant, I could put what? 1 plus tangent. And why is that good? Because there's a negative tangent coming up right over there, and they'll cancel each other out. See what I'm saying? So I'm going to go 1 with the tangent plus cosecant squared. So all I did is took this part right here and replaced it with that part right there. And then minus, I'm going to distribute this negative tangent squared x, and distribute the negative of the other part, negative cotangent squared x. And now that negative tangent squared and this positive tangent squared are going to cancel each other out. Okay? My problem's easier. I have 1 plus cosecant squared x minus cotangent squared x. And now the cotangent, the one with the coat, is cozy. And look at that. It's going to happen again. I'll replace this with 1 with, or wait a minute. Oh, okay. 1 with the coat is cozy. So if it's
Minus. Wait, no. No, it's cosecant minus 1.
I'm going to put the 1 over to the other side. I agree. Now cotangent is cosecant minus 1. So I'm going to replace this right here with cosecant minus 1. See?
You said it was.
And now that and that cancel each other out. And my final answer is a 1. And then this negative times that negative 1. And make positive 1. It's a 1 and a plus 1. 1 plus 1 is 2. Final answer is 2. I'll double check it. I'm just concerned about this negative here. The negative, and then this is all in parentheses, right? So yeah, I can distribute the negative so that the negative make a negative, negative 1 makes it positive 1. Positive 1 and positive 1 makes positive 2. Yep. I know you were just kind of joking about 1 plus 1 makes 2, but okay. Yes. Nope. Nope, it's not that simple. Sine squared plus cosine squared does equal 1. But there isn't a neato little saying about cosecant or secant plus, what were you assuming?
Cosecant and secant squared, like the two of them together would that equal 1?
Gotcha. It does not work. It would take me a long time to explain it, but I can tell you I would know it if that was a true one. So thanks for checking, but nope, you can't say those two together add up to 1. Yes?
Instead of rearranging one
So you want to go back to the original problem and change the cosecant squared x right here to what?
just do 1 plus cosecant squared x.
Yes. You're just going to do it in the other order. And, you know, when I do this first as cosecant, it's the one with the code is cosi, so 1 plus the cotangent. Yep, 1 with cotangent. Now my other cotangent will cancel, but then my problem is going to be I'll have to still do the same thing and get these two to cancel each other out. So I'll still have to do deal with the secant eventually. So you're just changing the order that you do it in, and I hear you. That might be easier, but it's going to both lead to the same answer of 2. Okay? But I hear you. Sometimes the way that I pick is not the fastest way. And when it's all said and done, there's a lot of times there is got to be a fastest way. But the goal is not that you do it fastest, is that you can figure out a way to simplify it and get it down to 2. Faster is better, though. So, okay, so moving on. Let's go on to different kind of problems. Sum and difference problems. We haven't done these in forever. 49A. Sine of 15. Thankfully, we did not make you memorize the little formulas that you need for this. Remember, this is the test where you're not going to get calcs, right? So how on earth can you figure out sine of 15? Only because you know that that's the same as sine of something plus something? No, because I haven't got sine of 5 or 10 memorized, but I do have sine of 45 and 30. I do know how to find those with a right triangle. So then I go sine of 45 minus 30 will be the same as sine of 15. Tough to argue with that, right? And if I can do sine of 40, I wish it was so simple as just distributing this. It doesn't work though. So what you have to have is a sheet, which we give you, that tells you what the difference one is. And that, you might not recognize it. Flip back to the behind the front page of your packet. It has this little statement I will write in lime green. Sine of alpha, it's not an alpha, alpha minus beta is, or plus or minus, does it say minus plus or plus minus? Plus and minus, like that, is equal to, and again, this is the little pattern, sine, then cosine, sine. Sine of alpha, cosine of beta, and it's the same sign. The plus minus means keep it the same. If they had changed that to a minus plus, it would mean to change the sign from whatever it was. But since that and that are the same, it means keep the same minus or plus. And then sine, cosine, and then it's cosine, sine. Cosine alpha, sine beta. All right, so there's the little formula that we give you on the sheet. Now, how do I translate that into an answer? I use sine, cosine, minus cosine, sine, and I just write in those angles that I have, 45 and 30, and 45 and 30. And now, this reminds you, you cannot just leave sine of 45 on this test, because if it's one of the angles we know, then we have to go use the triangles and figure it out. So sine of 45, here's the 45, 1 square root of 2. Sine is opposite of hypotenuse. Opposite, if I pick this angle, doesn't matter, they're both 45s. Opposite of hypotenuse will be 1 over root 2 for that one. And how do I do cosine of 30? I'll draw that in black. Here's the 30, 60, 90 triangle. 30, 60, 90. This is 1, 2, and root 3. And if I do cosine of 30, cosine's adjacent over hypotenuse. The adjacent's right there, over the hypotenuse is right there. Root 3 over 2. And what was I doing? I was multiplying those two. And now I subtract cosine of 45, which I can go back into this triangle. Cosine is adjacent over hypotenuse, 1 over root 2. And sine of this 30, I have that one memorized, 1/2. Comes in so handy. But if I wanted to look, sine is opposite over hypotenuse, 1/2. And then, handily, these have a common denominator already. So now I can just add the tops. Root 3 times 1 is root 3, and negative 1 over 2 root 2. Okay, at the end it was just simplifying fractions, and I did the top, that times that, minus that times that, and then the bottom is just the same, 2 root 2s. Okay, that was, if you know the little right formula to use off the sheet, that should be easy. Yes?
So, for
There's a different formula right under it on the sheet. I'll just start the tangent one for you. Tangent of 15. Same deal. I can't use plus because I don't know any of the 5s or the 10s or whatever. So I got to use bigger numbers and subtract. So I got to go with tangent of 45 minus 30. Can't argue that that's not the same thing. 45 minus 30 is 15, and that all works. But there's a formula for tangent, and it says it underneath that other formula. I do not have these memorized even myself. I used to at one point, but don't use them enough. Tangent plus tangent, or actually use the same sign, sorry. So it's tangent 45, same sign, tangent 30, over 1, and then it's the opposite sign, 1 opposite sign of what we're using, plus tangent multiplied times. And again, I go off to a triangle and figure out this one, figure out this one, figure out this one, figure out that one, and figure them all out, put them in as fractions. Final answer is a simplified fraction. Okay, that's how you do 49b. Let's go on to do problems like, one kid asked on part C, they asked a really good question. They said, can't I just do that as a number of degrees? I don't want to have to figure out 5/12 pi. I said, sure, you can do it as a number of degrees. You could figure that out as a number of degrees by saying, well, how many degrees would this be? And you go 5 pi over 12 times 180 over pi. And you could figure out how many degrees it'll come out to. That'll cancel that. And then this is going to be a little bit ugly, but I can do it. 6 goes into here 30 times, and 6 goes into here twice. And then that's 15 goes, or 2 goes in there 15 times, 2 goes in there once. And so the final answer would be 75 degrees. So couldn't you do this as tangent of 75 degrees? Yep. And that'd be the same as 90 minus 15. That doesn't really help. That'd be the same as, it's tangent of 75, that'd be the same as tangent of 45 plus 30. And then we're back to one of those again. So yes, you can change these ones that look like they are stuck in radians into degrees if you want to, and do them that way. Now, if you'd rather, we can make this into two things with pi. It's just they're going to have to be in twelfths. So like 5/12 pi, that could be two things being added together. Like it could be 3 pi over 12 plus 2 pi over 12, also known as, do you recognize this one? Pi over 4, plus that one, do you recognize it? Pi over 6, and you know the both of those, don't you? Isn't pi over 4 exact same thing as 45 degrees? And pi over 2 is the exact same thing. Pi over 6, sorry. Pi over 6 is that same thing as 30 degrees. So these would work just fine if you want to do it that way. But you got to use those formulas. All right. Cool part about this is that we're not distracting you with stuff. If it's on here, then there's questions in the final like that. Okay, so you're not wasting your time by learning how to do it. Now, if you're close to getting it and you're just like a question away and you want to ask during work time, that's the perfect use of our last hour here, is if there's something you're close to and you want to still try to get it. But to be honest with you, if there's one kind of problem that you've never gotten and you still are completely lost on it, it's probably not worth it at this point. Because there are going to be 28 questions and you can get many of them wrong and still get an A. Remember, you can get 75% in each section and still get an A. So if there's something that's really bothering you and you think you're close to getting it, ask. If you've always never got that kind and you're lost on them, down to as much time as we have, you're probably not going to have time to learn it. Maybe if you come to the review session tonight, we'd have more time to talk about something like that. But all right, we got to get done with this packet. We're getting close. Number 50. Number 50, part A. Sine of pi over 5, cosine of pi over 2. This is like the reverse. They're giving you like an answer to one of those other questions. Sine of Oh, cosine pi over 2. Gotta get that in there. Plus sine of pi over 2 cosine of pi over 5. Wasn't the pattern before sine, cosine, cosine, sine? But do you get I can just reverse these two because anytime you're multiplying, you can reverse it? So all of a sudden I'll have cosine of pi over 5 times sine of pi over 2. All I did is flip-flop those two because then it's the same pattern. Sine, cosine, sine, cosine, cosine, sine. See, I just reversed those two and now I got the pattern back. What's that pattern for? It's for sine. It's sine of something. And then what are the two things? They're right here and right here. And I use the same sign as that. So it's pi over 5 plus pi over 2. All I'm doing is doing the same kind of problem backwards. It's the same sign as whatever it was. When you're doing the problem Sine, S-I-N-E, the function sine, then you should use the same sign as whatever this is. So since that's a plus, I have to use a plus in here. Yes, sir. Where you change signs, that's in the middle of the tangent one, in the bottom of the tangent one, and then it says it on your sheet. And cosine. Cosine is the flipped sign from whatever you would normally have. So if you're doing cosine of this plus this, in your answer it's going to have a minus. All right. It doesn't say to, so you'd be fine either way, but reality is this is a multiple choice test, so if all the answers were in radians, you'd have to be able to handle that. If all the answers were in degrees, you'd have to be able to handle that. Okay, that was problems like number 50, part A, B, and C are all the same. 51. Oh, we're getting so close. Sine of 2x equals 2 sine of x. A double angle, what's going on? Ooh, there's an app for that. Back on the front page, there's a formula for that. Sine of a double angle, there's only one thing on the whole sheet that says sine of 2 theta equals something. You see it? Very last thing on the little list. Sine of 2 theta equals 2 sine of theta cosine of theta. So I can replace this right here with 2 sine of x cosine of x. It's a fact. It's one I wouldn't expect you to memorize, but it is on the sheet. So anytime you see a double angle, go to the sheet. Now, why is it any better now? Because now, no, you cannot do this. This is a really common mistake. You think you can just cancel them both off? You can't divide by a variable on both sides. You never could. It's one of those things we don't talk about much in the middle school, so I don't blame you for like not knowing this. But if I have 2x equals x, is that ever true? Yes, it is, if x equals 0. But if you divide by x on both sides, what happens? It says 2 equals 0. There's no such thing. But there is an answer. So bottom line is you can never divide by a variable on both sides. You can add a variable to both sides. You can subtract a variable from both sides. But you can't ever divide by a variable on both sides. So bottom line is, yes, you can divide by 2. But you asked, can you divide by sine on both sides? And because it's sine of x, you can't do that. If it had been a number like sine of 30, which is 1/2, you can do that on both sides because that's just a number. But if it's a variable, like sine of x, you cannot divide by sine of x on both sides. But what I can do is subtract it from both sides. Why is that any good? Because now it's equal to 0. Why is that good? Because then I can factor this, and if I have this times this equals 0, that's half of what we've been doing in trig, is trying to set these things up so that you got something times something equals 0, and then you set this side equal to 0 and set that side equal to 0. I'm talking about? So how do you factor that? I see a sign in both of them. So you pull that out. In fact, I see a 2 sign in both of them. So I pull that out. 2 sine x, just one thing in this parentheses, times what's left when I pull out this and this? cosine of x, and then when you're actually dividing them, so it's really technically leaving a 1 behind, minus 1. And now I say 2 sine x equals 0. So then sine x equals 0. And then I figure out where is sine equal to 0. And then that brings up another topic. When is it equal to 0? That can't be a triangle because the side can't be 0. So then you go, where am I? I'm either here or here or here or here. And this is 0 over 1. And remember the little formulas for sine? Y over r. Remember that one? So it's really where y is 1. No, y is 0. Where y is 0 is either here or here. So there'll be 2 answers for this one. All right, yes? Okay. Do you get that there was, in both of these, this and this, there was a 2 sine x? I actually factored out the 2 sine x from this, and I put it in the front here. Once I factor that out, I see what I have left is cosine x, and there's a 1 for a placeholder, like right there. Okay, and now I have 2 sine x equaling 0, and hold on just a second. All right, so I have, this one is, let's see, this is 1 comma 0, and this one over here is negative 1 comma 0, and those are my 2 spots where my answers are, because y has to be 0, and there's a y 0 here, and a y is 0 there. So, yay, those are my 2 answers, 0 and 180, or if you're using radians, it'd be 0 and pi, 0 and pi. Yes? Good question. If the directions say that they want the answers between 0 and 2 pi, where 2 pi is allowed, 2 pi and 0 are the exact same thing. So the only thing is, does it say in the directions the answers need to be between? 0 to 2 pi. But does the theta, is it allowed to be 2 pi or not? Okay, if it can it be 0? So then I should say 0. See what I mean? It's either 0 or 2 pi. It's the same thing. It's just that this formula here only allows me to use 0 and not 2 pi. So I'm going to use 0 for this, and I use pi for that. So there's my 2 answers for this side of the equation, and then I got to get 2 answers for the other side of the equation, and I think this is one of those ones where I hope you know where to go from there, so I'm going to let you go, and if you need help, ask me more later. Okay, moving on to 52. Almost to the back side of the last page. 52 is sine 2 theta. Oh, right away I know I'm going to have to go to that sheet. You know why? Because it says sine 2 theta. And I have no idea what to do with double angles unless I use that sheet. All right. So I'm going to go to the sheet, and it says, write it as one expression involving sine or cosine. So I'm going to change this sine 2 theta into, what's the sheet say again for that? 2 sine theta cosine theta plus cosine theta. Well, this isn't just one thing yet. They want us to get this thing to be just one thing. So then what if I factor out the cosine? Okay. And I have what's left? 2 sine theta plus 1. It's still not just one function. Doesn't it what? It's okay, I'm open to ideas here. No. I'm open to somebody. I think I could still figure it out, but I was going to see if any of you guys had any thoughts. It's not squared. If it was squared, we could do a swap. 2 sine, you know what I mean? Like, we could do like sine squared plus 1 is equal to cosine squared or something like that. How about this? Cosine, what? All right. The only other thing I can think of is if I want the co-function, like I really don't want cosine, I want sine. Do you remember the thing that does that off the sheet? It's one of these dealy bobs. Sine of pi over theta. No, pi over 2, sorry. Sine of pi over 2 minus theta would be the same as cosine of theta. You remember those? It's one of those kind. If all I have to do on this is get it down to be either sine or cosine, either one, I'm going to take this simple one, cosine, and replace it with something it's equal to that has only sine in it. And that would be sine of pi over 2 minus theta. That times 2 sine theta. Didn't I get it down to just one function? Oh, yes, I did. It's only got sine in it. Get what I did there? I needed this to have only one thing in it, so I found this. And the way to get the cofunction of that, which is sine, is to use that cofunction formula that's on the sheet, this one. That's equal to that. So now it's only got sine in it. All right, moving on to number 53. Oh, painful. I thought we were farther than that. Okay, number 53. How about this? We need to take a short break. If nothing else, I need to take a short break. It's hard to concentrate that long in a row. I'm going to pause for a minute while you guys relax. All right, we're back from the little break there. Here's number 53, part A. It says, state whether the function is an exponential growth or exponential decay. This one's really tricky because it looks like it's decay from that. But then they put it to the negative x. And when you have something to a negative exponent, it puts 1 over that, so it's really 1 over 0.75, which is a positive 1 point something. So that's actually growth. Get what I'm saying? Because they threw in a negative in the exponent, you have to know how to handle that. That turns this into 1 over 0.75, which is growth, not decay. Okay, what? I'm not sure exactly what it is. I suppose I could go, yeah, that's a good idea. I could go 1 over 3/4. So make it 4/3. Good idea. So I could go y equals 4/3 to the x. But the only real question was, is it growth or is it decay? And describe its end behavior using limits. So now that I know it's growth, now I can go, okay, then generally it looks like one of these guys. So now how do I write limits for that? All limits start the same way. Limit of the function as x approaches whatever is underneath the limit, and you have an equals there. And then this number right here is the x, and this number right here is the y when you get there. X equals, if I go way over here, x will be infinity. And when I get there, it would be way, way up there, so it would be positive infinity. So the limit of the function as x approaches infinity would be infinity. And the limit as I approach negative infinity would be 0, because it would be really, really, really close to 0. They call it approaching 0, because it never actually gets to 0. All right, that device needs to go away right now. Away, where it won't be just picked up again in 2 seconds. All right, moving on to number 50. What was that one? 53. So 54. Number 54. Oh, wait. On the other ones that are a little more challenging there, let's do 53D for a second. I think it's worth it. It's got a 1 minus in it. That's a good thing, because it tells you the growth rate in there. When it says 1 minus 0.7, remember that this is the factor. The factor is 1 minus the 0.7, which is a 0.3. But the decay rate is right here. That's 70% decay. You get the difference? If they asked you what's the growth factor or the decay factor, it'd be 0.3. But what the growth rate is this. Anyway, no matter how you slice it, it's decay, so it goes down like this. You should know what that generally looks like. And then the starting point is right there. The starting number 2, that means that's 2. And since it's 0, it's 0, 2. All right, and now I'm going down. So now all I have to do is write the limits for it, and again, it's going down. So this one is the limit as function approaches infinity would be 0. And as it approaches negative infinity, it would be infinity. Okay. On to 54. This is those exponential kinds. These are, I think, fairly fresh in your mind, because we just had a test on that reviewed these. But if I have 800 on the top, that means that the limit to growth is 800. Done. And then I have this 1 plus, and it says 90 e to the negative power. And that's okay that that's e to a negative power, because we expect a decimal right there. And that's 1 over e, which would be e is 2.718. And then this is to the negative 0.2t, 0.02t. Nope, not a 0 in there, sorry. 0.2t. There we go. Okay, what do they want? They want the initial population. That's easy, it's 90. No, it's not. That's not the starting value. So often people think that's the starting value. It's not. The starting value is where it's the same as the y-intercept, right? Wouldn't you agree that the starting value is the y-intercept? On a problem like this, they kind of top out like this. It's that number right there. That's the y-intercept. Finish this sentence. The y-intercept is where x equals 0. And in this case, it's a t. But so I just have to put in a 0 right here. Once I put in a 0 there, this becomes 0. And e to the 0 becomes 1. And then the y-intercept will be 800 divided by 1 plus 90. 800 divided by 91, and that's some decimal, and that's your starting value. Okay, so your starting value is the y-intercept. The y-intercept is where x is 0, so you stick in that t is 0. Okay, when will the number of people be 600? Well, how am I supposed to put that in? It's when will it be 600? Should I put a 600 in for the time? No, that doesn't make any sense. Should I put a 600 in for the e? No, e is 2.718. Can't put it either of those spots, so the 600 has to go here. So you'd set up an equation like this, and you'd solve for t. I have a great way that works on any long, nasty equation. No, you won't have an answer key for the final, but you do have a graphic calculator, so what could you do?
Wait, we do that one?
No, wait. I'm sorry, you don't in this kind of a problem. Nasty, I forgot. My HA class that I just taught last hour, I kept on going back to, you know you're going to have a calculator, so you can just do this. I was thinking graph both sides and see where it crosses. That's what I was thinking. But you can't on this kind of a problem because you don't have a calculator for this final. So how do I get the t alone? I got to do the long way and multiply this all out. And go 600 times denominator here, 1 plus 90 e to the negative 0.2 t equals 800. And then I have to divide by 600 on both sides. And that gets rid of this 600. Then I'm going to subtract 1. So 800 divided by 600 cancels a little bit, and you end up with 8 over 6, which is the same as 4 over 3. And then I'm subtract 1. So now I'm down to 90 e to the negative 0.2 t equals 8/6, which is 4/3. And then I'm getting rid of this 1 here, so I'm subtracting 1. And that's 1 1/3 minus 1, which would just be 1/3. And now I can no, wait, I got to get rid of the 90. So now I'm going to divide both sides by 90, which is the same as multiplying by 1/90th. So this would be e to the negative 0.2 t is equal to, I'm getting rid of the 90 by multiplying by 1/90th on both sides. 1 over 270. And then I have to do a rewrite. ln log base e of 1 over 270 is equal to negative 0.2 t. And the very last thing is t alone yet. You got to keep asking yourself, what am I trying to do? I'm trying to get t alone. Divide by negative 0.2 on both sides. That cancels that. T is alone. There it is. That's messy, but that's how, there will be some answers. I've seen the final. There are some answers that are like that, where you just have to solve it, just like I just did, simplify it as much as you can, and then you'll get an answer that's not a nice number, but there'll be answers like that to choose from. Scroll up. Like, oh, you mean like higher it so you can see work, okay. So the process was, it gave me 600. I stuck it in on this side because I couldn't put it in as a time or e, because those don't make any sense for a 600. And then I solved it by multiplying both sides by this. And then I had a 600 right here. And I got it off of there by dividing by 600 on both sides.
I was talking about kind of like the last couple of steps.
Okay. All right. Do you remember that 8/6 over here turning into 4/3? Did that make sense to you? It was just 8/6 is 4/3. And then I was getting rid of the, I was subtracting 1 from both sides. Remember to get rid of this 1. So I take away 1. 4/3 is the same as 1 1/3, right? So 1 1/3. 1 1/3 minus the 1 is 1/3. That's where I got the 1/3 from. And then I did the 1/3 times 1/90th because I was getting rid of this 90. Okay. We've made it to the last page anyways. So let's look at 55. Number 55, part A, initial value is 5. I'm trying to think, is this one of those exponentials or is this, no, it says exponential. So I know it's this. All right. So I'm going to say initial value is 5. I'm going to slap a 5 right in there for A, and I can do that on that kind. On the logistic kind, it won't work, but initial value is 5. I can put a 5 there. Increasing at a rate of 17%. Most common mistake, people put in a 17% right there. You can't just put the 17% in there. What do you need? 1 plus 17%. There we go. Done. That's it. Okay, if it had been decreasing, I'd put a minus in there. And like on the next problem, it says initial value 2, so I put a 2 here. And then it says decreasing, so I put a minus there. And then it says rate of 0.59. That's just see if you're really paying attention. 0.59% is less than a half a percent. It's 0.0059%. See? 0.59% is 0.0059. All right. How about C? 55C. If it throws in something like every 6 years, you do have to pay attention to that. So if I have y equals ab to the x, and I say initials 592, so I go y equals 592, and then I need something there to the x, and it says having. You can say 1 minus a half, which is the exact same thing as 1/2. And then that every 6 years, what am I supposed to do with that? Okay. If I put a 6 here, or should I put it over 6? Over 6. Now, if you wanted to go and, okay, remember the kind where if it's happening every 3 days, we go divided by 3, and then we say in days? Well, this one says it's happening every 6 years, so I'd say divided by 6 in years. Now, could I do that another way that gets me that 1/6? Yup. It tells me by saying that it halves once every 6 years. Wouldn't you agree that that means that 6 years from now would be like X, I would have half as much. I would have 592, except I'd have half of that. So it'd be 250 and half of 46, 296. 6 years from now, I'd have 296. Do you get what I just did there? That's a point in the future. 6 years from now, I'd have 296 grams of the stuff. Okay? Then I could use that and plug it into the X and the Y and figure out what that little factor is. But it's a lot easier to just know that if it says it's happening every 6 years, that I can put a over 6 like this, and then say in years. Now, the other thing I could think of on this is if I wanted to just put in a 6 here for the X and figure out what Y is, but all it's going to tell me is 6 years from now, how much will it be? And if you think about this, if I didn't have the divided by 6, if I put in a 6 here, 6 years from now, see how this 6 divided by 6 turns it into a 1? And then 1/2 to the 1 power makes it 1/2 of whatever it used to be? I don't know if that works for you. The reason this has to have the divided by 6 here is because then 6 years from now, it's supposed to be a half, right? So then I stick in a 6 years. It wouldn't be, if I didn't have this divided by 6, I'd have some really tiny number for it. But that's why it needs that divided by 6 there. Because when I put in the 6, 6 divided by 6 will equal 1. And then 1/2 to the 1 power means it'll be half of this. And that's what I want it to be. So anyway, long story short. Too late for that, I guess. But long story. If it says in 6 years, put it divided by 6. Yes. Same thing, exact thing as x over 6 is the same exact thing as 1/6 x. Just be careful with that. So often kids will let that x kind of drift, and all of a sudden they think it's 1 over 6x, and that's totally different. If you have x over 6 is fine. 1 over 6x, where the x is kind of in the middle, is okay. Or the x being on the top, I think is the best. All right. That's 55, a couple different parts of it. Let's move on to 56. That one's a basic logistic where our initial value is 10. So basically it's like this kind of a guy where this is 10. And the key to it is knowing this is 0, 10. And then I can just plug in my numbers into this big formula thing. I've done enough of these that I don't really want to do this one entirely again. Its limit to growth is 40. 1 plus ab to the x. I got to figure out a by using this. Put in a 0 here. Put in a 10 here. Solve it. And then I figure out the b by using the other point. The other point in this case is 1, 20. 1, 20. I figure out b by sticking in x is 1 and y is 20. And then solve for b once I have already put in a. So always start by solving for a. Don't take this 10 and stick it in the a. It does not work. You'll have to solve for the a. Okay. And the very last question. Whew. Population of field mice in Carver County after 1 month is modeled by the function. All right, 250. Okay, it's like this. Over 1 plus be to the negative 0.8t. All right, and this is the population. Is it 0.08? Okay. There we go. Okay. Now, what is the initial population? No, wait. What value for B will yield an initial population of 100,000? Can I just put the initial population right there? Absolutely not. Remember, the initial population is not ever right there. But if we're drawing our little picture and we put it like this, we say this is our initial population needs to be 100,000. Doesn't that mean 0, 100,000? So that means I could solve for B by putting in 0 for x and y is 100,000. This is 100,000. That's a population. Doesn't it make sense it would go there? And then this is the time, is time 0. That means starting. And when I could do that, I can solve for B. It'll take you a while, but that's how you solve for B. And the last question, part B, what is the most mice that the habitat of Carver County can support? The most is right there, 1,250,000. That's a really easy question for the last question of the packet. Okay, now I know you haven't done all these. Well, there's probably a couple people that have, but if you have not done all the problems yet, honestly, I strongly recommend you do every single one. If you do like part A and think, oh, I get this, part B can be so different than part A. Don't just assume that, oh, I get it from the first problem. Every single one of these is a little different, a little bit of a twist. You know, different kinds of problems you have to know. And we do have about a half an hour left. We're done at 12:05, so we have actually 36 or 37 minutes left. So you'll have some work time in here. Otherwise, I am running a little help session tonight at from 6 to 8 p.m. in room 1430. Otherwise, if you want to come in the morning tomorrow morning, that can work too. Tomorrow morning there's a help session before school. All right. So 1430 is this room right here. Okay. That's all I got for you for today. And good luck on the final.